we're given an array and we have to find a subsequence such that it's in increasing order. For example, if I take 3, 7 and 8, so I have three numbers and they are in increasing order, and I can take numbers from any position, they don't have to be contiguous, and I have to take the largest number of elements possible. For example, if I take 2, 7 and 8, I'll get only 3 numbers. But if I take 2, 4, 7 and 8, I'll get 4 numbers. If I take 2, 4 and 9, I'll get only 3 numbers. So I have to find the largest increasing subsequence, or the maximum number of elements that can be taken in an increasing order, forming a subsequence. So we'll be doing this using dynamic programming. So we'll have a integer array called lis. In lis of I will show the longest increasing subsequence till I. So what I'll do is I'll find the length of the array. So we have 1, 2, 3, 4, 5, 6, 7 elements. So lis will also have 7 elements. So lis of 7. Now I'll initialize the first element as 1, and minimum all the elements will be 1, because even if all the elements are in decreasing order, if no two elements form an increasing subsequence, still the longest increasing subsequence will be 1, because every number itself also forms an increasing subsequence. Now I'll run a loop for int from 1 to n, and then I'll run a loop from the back. So for example, if I'm at 4, then I'll be checking all the elements before 4. So for int j is equal to I minus 1 to 0, all the elements before I, j minus minus. Now if I'm at 4 and on the back, if I have found an element which is lesser than it, then I've found at least one increasing subsequence, because I have this number and on the back I found a number smaller than that. So if a of j is less than a of I, then, and one more thing, because there can be multiple number which are lesser than the one we have. For example, before 4 I have 2 and 3, so I'll be taking the maximum value of lis. So let's say maximum is equal to 0. So maximum is equal to max of maximum comma lis of j. So I'll be running a loop from my current element to the back, and if I find an element which is smaller than the current element, then I'll find the maximum value of lis, and then my value, the current lis value, will be that plus 1. So lis of I is equal to maximum plus 1, because before that, for example, if I come from 4, so before that till 2 I had one subsequence, and now we've got 4 also. So whatever increasing subsequence we had till before was maximum, but now we've added current element to it. So for the current element, the longest increasing subsequence is the increasing subsequence before plus 1. And that's pretty much it for creating the lis array. So what I'll do is I'll just show you the elements of lis array. So you'll have a better understanding of how it's working. And as you can see, the maximum value in lis array will be a final answer. So I appear to have made some mistake. Yeah, n is not declared, so I'll just say n is equal to 7, because n is the length of the array. And here we go. Okay, I should remove the end line. Yeah. So there we go. So as you can see, we can contrast this to the array. So for 3 initially we have 1, and for 2 we didn't find any element lesser than this, so it will just stay 1. And for the next element 4, I went on to the back and I found 2 elements lesser than that, and all of them had LIS value as 1, so the maximum was 1, 1 plus 1, 2 for 4. Then for 1 on the left, I didn't find any value lesser than that, so it stayed as 1 because maximum was 0. And then for 9, I found one element lesser than that, that was 4, and the value of 4 LIS was 2. I also found 2 which was lesser than 9, but the LIS of that was 1, and the maximum LIS I found was 2. So 2 plus 1, 3, which I got for 9. Likewise for 7, in the back I found many elements lesser than that, but 4 had LIS as 2, and 2 plus 1, 3. And for 8, I went on to the back, and for 9 and 7, I had LIS as 3, and the maximum is 3, and maximum plus 1 is 4. And I had initialized maximum as 0, so if I haven't found any element lesser than the current element, then the LIS for that element will just be maximum plus 1, which is 0 plus 1, 1. It means that simply the increasing subsequence till this element is just this, if its LIS is 1. And the final answer is the maximum of that. So we'll just do that also, because otherwise it's not just complete. I can reuse maximum. So maximum is equal to say 0, and maximum is equal to max of maximum comma LIS of I, and that is the final answer. See out maximum end line. For this, the maximum is 4. And as I said, 4. But do remember that, as you can see also, that the time complexity of this, even though it uses dynamic programming, the time complexity of this is O of n square. And you can do this in O of n log n, but that is using a different approach. And I just showed you how to do this using dynamic